Hello everybody, we are starting our next section of the surface area and volume chapter, and this section is going to cover solving the surface area of pyramids and cones. So, our previous section we looked at prisms and cylinders, and today we're going to look at pyramids and cones, and we're going to identify how are those different than what we looked at before. So let's do a little bit of review before we dive into plugging and chugging. Last week we identified some names for some 3D figures, and we're going to add a little bit of vocabulary onto that. So let's look at our little review box in the right-hand corner. Review. What is a prism? A prism is going to be a solid with two bases that are congruent and parallel. The difference from that, as far as a pyramid is going to be a solid with one base and face, that should not be plural, and face that meet at a point. So you have a pyramid if you have one base, you have a prism if you have two bases. That's why in our equations last week, we had to multiply by 2 to count for that additional face. You'll notice in the pyramid formulas, you do not have that, you do not have a 2 to account for that extra face. Similar to prisms, we like to further classify pyramids based on what that base shape is. So if my base shape or base figure is a triangle, we call it a triangular pyramid. If our base is a rectangle, it's going to be a rectangular pyramid, and so on. Hexagon, a hexagonal pyramid. We have another more classifying name for a circle, if we have a circle face, and that's going to be a cone. So a pyramid with a circular base is a cone. You are going to get two formulas today. One is going to be for pyramids, and one is going to be for cones. So let's dive in. If you have a pyramid, you're going to have those two equations, one to find that lateral area, the space between the point and your base, and then another one for your surface area. That lateral area component is integrated already into your surface area formula. So you don't have to memorize that, but I do want to point out that that's where that formula comes from. In pyramids and cones, you're going to be given this variable, L. It's not length here. It's known as slant height. So slant height, or your L, is going to be this component right here within your pyramid. Because you have your normal height that meets from the point down to your base, that slant height is going to be that cattywampus. Your normal height will meet to where it is perpendicular with the base. Your slant height is not going to be perpendicular to the base from that top point. And then finally, that capital B is going to be that area of the base. So for a pyramid, our formula for surface area is going to be 1/2 multiplied by L by P, the perimeter of the base, plus B, capital B, that area of your base. So let's do an example. Find the surface area of each pyramid below. What I like to do first is identify, okay, my variables so I can plug and chug. So what is my slant height? Well, that's going to be this 11.7 meters. My perimeter of my base. I did not draw those dashed arrows in the back. See, I'm pretty good at drawing normal figures, but once we get into the 3D figures, that's where I get a little cattywampus. So these measures are going to be congruent. So if to figure out the perimeter, it's going to be 8 times 4, or 8 plus 8 plus 8 plus 8, gives me 32 meters. And then finally, for my area of my base, remember, area of a rectangle, length times width, is going to be 8 times 8, which gives me 64. Now it's a matter of plugging and chugging. So my surface area is going to equal 1/2 times my slant height, 11.7, times my perimeter of 32, plus my area of my base, 64. Okay, a little bit of review. What does this component equal? Not the number. What is this? That's my lateral area, my space between my base and my point. We're over here. This is the area of my base. A little bit of vocab. All right, let's multiply that out. So 11.7 times 32 divided by 2 gives me 187.2 plus 64, giving me a surface area of 251.2 meters squared, because this is an area, so my meters are going to be squared. Let's look at another example. We're going to find the surface area of the pyramid. This is another version of how this problem will be given to you. And you have to do an additional calculation. So, in order for me to solve for surface area, I need L, P, and B. It does not give me L. So I need to find my L, or my slant height. How can I do that? Well, when I have a pyramid, I know the height is going to be perpendicular to the base. And it meets right in the center. So because we have this imaginary triangle that cuts through our pyramid that we can use to figure out our hypotenuse or our slant height. So let me pull that triangle out. Okay, that's going to be 3. This is going to be a slant height. In order for me to use Pythagorean theorem to figure out what this L is, or my slant height is, I need to know what this segment is. Does anybody have a hint of what that could be? Well, if this is perpendicular, it's going to divide this segment in 2. So I can divide my base length in 2 and get this segment. So 16 divided by 2 gives me 8. Now that I have that quantity, I can use Pythagorean theorem to solve for my slant height. So 8 squared plus 3 squared equals L squared. So 64 plus 9 equals L squared. 73, right? Did I add that right? Yeah, I'm good. Woohoo! Equals L squared, and take the square root to give me a decimal number of 8.54 as my slant height. All right. Now it's time that I have my slant height. I got my L. I'm going to rewrite this down here so I have some room. What is my P? What's my perimeter? Let me 16 plus 16 plus 16 plus 16, which equals 64. And then I need my base area, so 16 times 16 to give me 256. All right, plug her in. My surface area. Surface area is equal to 1/2 times 8.54 times 64 plus 256. 8.54 divided by 2 times 64 gives me 273.28 plus 256 to give me a surface area of 529.28 feet squared. Winner, winner, chicken dinner. All right, let me know if you have any questions. Our last component is going to be our cone section. And it's going to be similar to how we conduct the cylinders. It takes that lateral area of pi times r times L, our slant height. Okay, and then for our surface area, it's going to be pi r squared, the area of my base, plus my lateral area, pi r L. So looking at this example over here on the right, I'm trying to find the surface area of each cone. In order to use my surface area formula, I need my radius and I need my L, my slant height. So my radius is going to be 7 meters. My slant height is 11.4, so I do not need to do any more additional calculations. I can just plug into my surface area formula. pi r squared, which would be 7 squared, plus pi r, which is 7, times 11.4. Woo. All right, this simplifies down to pi times 49 plus, let's see, pi times 7 times 11.4 gives me 250.69 and some change. Plus, I'm going to use parentheses and I'm going to type in 49 times pi into my parentheses in my calculator to give me a final answer for my surface area of 404.64 meters squared. Okay. All right, let's look at one more final example. Here we are trying to find the slant height of the cone, so I'm trying to solve for that L. There's two ways to go about this. You can either, number one, plug all your information into your equation and solve for L, or you can rearrange your equation, then plug in your information. Whichever way works. I'm just going to plug in our info. All right. For me to solve for L, I need to know surface area, which is going to be 822.78 centimeters squared, and I need to know my radius. Provided to me is the diameter, that 18 centimeters is the diameter. However, divide that in 2, and I get 9 for my radius. So I have all my information. Now it's a fact of plugging and chugging. So I'm going to set my surface area equal to pi r squared, so 9 squared, plus pi times 9 times L. All right. Rewrite this. 9 squared is 81. 81 times pi. Oh, let me type it in my calculator. Is 254.469 plus 9 times pi is 28.274 and some change. I'm going to subtract my 254.469 from my 800. Oh my goodness. To give me, man, this is a lot to type in, 568.311. That's going to be equal to my 28.274 L. I'm going to divide by 28.274, divide by 28.274 to get that L by itself. So my slant height is going to equal, drum roll please, 20.10 centimeters. Ta-da! We did it! Woohoo! All right, that's all I have for you today. If you have any questions over this information, please let me know.